Hi, I'm going to shatter this bunny without any simulations, just some displacement tricks using the concepts that I have been talking about. And so this mesh is made of pieces that I fractured in Modeler. As you can see, for example, I select connected here, you can see that what goes on. And so the first thing that I'm going to do is to bake the information about those pieces. So I'm going to have this null, and this null is animated on the z-axis. And let me see, I'm going to turn off the auto refresh master plugin. I'm going to use it in the end. It's probably going to be more friendly than the Studio Live, but for now I'm going to keep Studio Live running. And okay, so first thing I'm going to do is I'm going to go into the displacement node editor of the bunny, and I have here part move, and so I'm going to displace the bunny with the position of each part, and I'm going to save that as an endomorph. So in this case, this endomorph will be called opos, just like the output port. And then I'm going to save the index. So I'm going to do make vector, and I'm going to put the index in the X channel. And so now I have the pieces distributed along the X axis. I'm going to add a small value in there to avoid floating point errors. Sometimes with some floating point errors, it will make the value jump from one index to the other. And so I'm going to put here, let's say 0.1. Right, so that little displacement allows me to fix any possible floating point error. And so now I'm going to save this as an increment. So save object. No, actually, I first have to save the endomorph, so index. And now I'm going to save object increment. Right, and so now I can delete this. And you notice that if I bring here a morph node, I have access to both of those information. So I have here index and I have opos. Great. So now even if I come here to Modeler, you'll notice that I have here the two morphs going on. Right, so first thing I want to do maybe is, let's say, okay, first thing I might want to do is to basically blast the pieces in a perpendicular direction to the movement or to the direction of this null. So this null is going to move on the z-axis, and so I probably want to have the pieces to move away in a perpendicular direction. So a way to do that is to use here this project vec dot. So that allows me to project one vector on another vector. And so I'm going to use the item info, and I'm going to set this to fall off control. And so I want the forward direction of that null. And what I want to project is the position of the pieces. So if I put this in here, what comes out of line vec is their projection along the direction that I'm giving, and what comes out of plane vec is the projection on the plane that is perpendicular to the direction that I'm giving. And so don't forget here with the displacement, you could replace this input with add. So in this case, I'm just adding, and that's why you're seeing the things as you're seeing. Now, I want these positions to be normalized because, of course, the pieces that are closer to the axis will get a smaller value than the pieces that are far away from the axis. And so I'm going to normalize this, normalize. And so now all of them get the same offset, and that sort of makes this whole. And now you'll notice that if I rotate this item, that the whole direction also changes because I'm using this projection here. Okay, so now I have the pieces being moved away in a perpendicular direction to the axis, but maybe I want some randomization. While I don't want the ones that are closer to the axis to not have as much displacement, maybe I don't want all of them to have the same exact displacement. So what I'm going to do is I'm going to scale this vector, and I'm going to scale it by a random scalar. And so I'm going to get that random scalar with the indices of the parts. And so I'm going to pass the indices through a random scalar. And so now with this, I'm going to get some random lengths for those vectors. Now I don't want this to start at 0 because I actually want this to not have sort of a hole that goes through. So maybe I'm going to put here something like 0.3. Okay, so now that opens up a hole in there. Now let's see, something else that I might want to add. Well, I might want to also have the pieces to move in the direction of the null moving through. So I'm gonna, let's say, put add for this one, and let's say that I want to add a bit of the position or the direction of the null. So in this case, I'm going to put here not 100%, but let's say 30%, so that they are displaced a little bit along the direction that the null goes, or maybe 40%. Okay. So another thing I want to do is to have some randomness in the direction that they take. So now at the moment they are all going in a perfect perpendicular direction from this direction. Maybe I want to add some noise to that. I can do that in several ways. I could, for example, just plug a turbulence there. And okay, this is not going to work because the turbulence is evaluated, it's mapped per vertex, and so it's not, in this case, it's not mapped per part. And so I would have to do a replace spot where I would put the bump in here, where I would put the part position and the replace in the object spot, and now I would put this in here. And so you can see that there's some randomness in there. If I just plug this into the output, you can see that there's some randomness in there. It's okay, but I think I want to use that that compound that I have in here called random vector. So I'm going to use the instances index, the parts index again. And so if I just put this in here to see the result, you can see that's yeah, it's quite the blast. So I'm going to scale that because I don't think I want the full force of that. And so let's say that I want, yeah, 40 looks okay, just to give some noise. And so I'm going to add this into the other ones, and this is what I get out of the blast. Okay, so now that I have sort of a blast effect going on, I want to have a control value, something that makes the bunny go from this state into this state. And so that's where the null movement comes in. So in this case, let's see, I want to create a fall off that works along the z-axis. And so here I'm going to use this line pose output, and I'm going to output that to, let's say here, the store material. I think I have those connected. Let's see if I have this connected. Yeah, so at the moment, let me turn off displacement. At the moment, this looks like this because I have to subtract the world position of my control null. So I'm going to subtract, and okay, and okay. Right, so at the moment the bunny is black, but as I move, as the null comes closer, well, actually, world, yeah, I put the forward, so that was a bit silly. Okay, so as the null comes closer, you can see the sweeping effect going on, and so this will be my fall off. So in this case, this is 0, this is 1. I actually want the other way around, so that I have nothing here, but I have the full effect in the back. So I'm gonna have here subtract, scalar subtract, and I'm gonna put 1 minus the value here, and so this is a bit more like it. So now this part, the bunny will have no displacement, and then the white comes in and I get all the displacement. I also want to avoid to go into negative values. So here I'm looking at this and it's all black, but I actually have negative values going on in there. So I'm going to put a max node, and I'm going to just leave it at 0, so I don't have negative negative fall off intensity, right? And so let's see what I'm going to do next. I'm going to basically just scale all these 3 displacements by this fall off. And so if I put this in here and if I connect this in here, let's see what happens when I go through the timeline. Okay, so now I have a nice transition between the whole bunny and it's being shattered into pieces. Okay, so let's add some more things. Maybe I want to have some rotation, because when things are being shattered, they also spin, and so this is very on that department, this is very still. They're all keeping the same orientation. And so let's see, how can I do that? I'm going to use this transform 3D compound instead of just plugging here the displacement, because it will allow me to scale and rotate my parts. And so if I just put that in there, and let's not forget that I'm going to have to use the delta here. And so now with the delta, nothing is being done at the moment, but if I put this on to translate, I'm just basically going to get the same thing that I had before. But I can also rotate and scale. Now I want the scaling and the rotation to happen around each part, not around the origin. So what I will have to do is I will have to plug in the part center into the center input. So this will guarantee that whatever I do on the rotation will be around the part center. So how do I find how do I rotate these pieces? Well, I could just, for example, add here the random vector, and I could just maybe scale it by some amount, let's say by 200, and that would probably do it. As you can see, well, I would have to scale that by the fall off. So let's see here, if I put the fall off in here, put this to rotate. Okay, actually I could put the fall off after everything, right? I guess I could put nah, let's leave it. Let's leave this as it is. So you notice right away that the rotation makes all of this to be much slower. So I'm going to turn off Studio Live, going to turn on the auto refresh plugin, and you can see that there's some random rotation. So now these pieces are rotating randomly, but well, I don't think I want them to just rotate randomly. So I'm going to take off here the translate so we can see the rotation better. So here they are rotating randomly. And well, I don't think I just want them to rotate randomly. I think this is fine, and it's probably I could also have some random rotation going on. But I think I would prefer to have the rotation happen like in a perpendicular direction. So let's say that I have. Say I'm gonna copy this, print screen this here, I'm gonna paste it in here. And so I would probably want to have, let's say I have that perpendicular direction, and maybe I want the rotation to happen like this. So something like this, like this, like this. Let me put white like this, like the axis to be sort of like this, so that everything rotates around this axis, with this axis in mind. So how I can do that is by taking into account the line position, or I can just use the here the forward, and I can do a cross product with that and the perpendicular direction. And so in this case, let's see, if I have the perpendicular direction. So let's see, for example, this one, I have the perpendicular direction, I have the forward direction like this. If I do the cross product, I'm going to get this axis. The same, for example, for this one, I have the perpendicular direction, I have the forward direction of the null, and so this will give me here this axis to rotate this piece. So I can have that sort of rotation that I was talking about. So I'm going to do a cross product, vector cross, and let's see, I'm going to put a cross product between the perpendicular direction, the plane vec, and the forward. So this will be my axis of rotation. So I'm going to put in here a rotate node by Akira Azagi, the one that rotates a matrix. I'm going to put the axis in here, and I'm going to put HPB, matrix HPB. So I can convert this into an Euler rotation that I can plug in here. Okay, so if I just plug in here, now I need an amount of rotation, and so I can use the fall off for that. So if I just plug the fall off in there, let's see what happens. Okay, so now you can see that the parts start to rotate like they are peeling away from the center, and this gets this shape like a pineapple or a pine cone. And so you can see, yeah, so this is the sort of rotation that I wanted. It looks like a peacock lifting the feathers. So yeah, this is the type of rotation that I wanted. Now maybe I want more of it, and this fall off doesn't rotate them enough, so I'm going to multiply the fall off, scalar multiply. And I'm going to put this in here. I'm going to multiply this, let's say, by 12. Maybe it's too much. 6. Okay, see. It's going to make them rotate like this. Yeah, this seems fair enough. Now you see that they go around. I think this is fair enough. So okay, I want this rotation, and well, maybe I don't mind to have this this noisy rotation here as well. So I could say, let's see, put here to 50, and going to add, so to HPB add, I'm going to add these two. So I don't mind to have some noise, some random rotation in there as well, even though that's not what I want to be the most expressive rotation. So here I have without any noise, and here with noise. Let's see, how does that look like? Funny. It looks even more uniform with noise, to be honest. Okay, so now it got quite noisy. Okay, so this is the rotation. To me, I think it's fine. So as how I put the translate in here, and let's say I come to frame 40, this looks quite a blast. Now what I'm going to do is maybe I want to also have some changes into the scaling. So I'm going to take the rotate, since it seems to slow down the setup quite a bit, and I'm just going to look into the scaling. And so I also want the scaling to be related with the fall off. And so what I'm going to do is I'm going to put here, let's say a box step. No, not a box step. Maybe a remap. Yeah, I'm going to put a remap. And so I'm going to put this scalar in here and this in here. Right. And so I'm going to use another random scalar, and let's say from 0.5 or 0.2, yeah, from 0.2 to 0.5, something like this. And so okay, I have this fall off, and I want when the fall off comes in, so the fall off goes, let's see, from 0 to 1. I want this to go from 1 to 0. And so as the fall off settles in, you'll notice that I will have the pieces just scaling into nothing. Right, but maybe this distance is, well, yeah, I'm gonna have to clamp the values there. And yeah, if I don't clamp, that goes into negative. But okay, so I have now the bunny disappearing into nothing by scaling the pieces down. But maybe I don't want all the pieces to just basically completely disappear. And maybe I want this to be something that takes place a little bit after I see the shattering. So maybe I want this to be from 1 to 2 instead of 0 to 1. So it's further down the line of the shattering, right? So now I see more of it, and then they disappear. And maybe I don't want them to go completely to 0. And so I'm going to use these random values here that go from 0.2 to 0.5 instead of just going to 0. So now if I scrub this timeline in here, you can see that I still see some pieces even though they get quite smaller. Okay, so I think overall the shattering effect is done. Let me put here the rotation, and so I can have a grasp of the full effect. This is becoming quite slow. I'm pushing the boundaries here. Probably I do a preview, so we have a notion of the effect. So that's what I'm going to do. I'm going to do a preview, quick preview in here. So I'm going to make a pause and do a preview. Okay, so back from the preview, you can see that this is what I get. And I think it's fair. It's looking like I wanted, and maybe I would just add a little bit more movement in the direction of the null. So at the moment, I don't think the pieces are moving much forward in the direction of the null. Well, maybe they are. Yeah, I think they are. It's just the angle I was in. It's like they're being swept away. Yeah, they are moving in the direction of the null. Okay, so this, in terms of displacement, I consider it done. Let's look at some shading just for fun. And so I'm going to turn on VPR in here, come into this, let's say, let me come here into the exterior, turn off here the fall off that I was using just to check the fall off, and turn off the interior. I'm going to turn off the diffuse shading here so I can see that what's going on. So I'm going to select here, I'm going to have some random colors going on. And so I'm going to use the index of the pieces. So you can see now with this, I get some random colors. Moreover, I'm going to use the fall off. If you remember here, I'm using this get material to get the fall off from the displacement. So if I come in here, you see that I have this line position going into store material, and I have this fall off scalar saved in there. And so when I come here to the surface editor, you can see that I'm getting that value. So in this case, I'm getting a little bit of a transition between one color and some rainbow colors, as you can see. And in the particular case of the exterior parts, I'm shading this with the edge node by Denis Pontonnier, as you can see in here. See, okay, that's the edge node, the look of it. So I'm using this to sort of hint that the fractures of the bunny are cracking, and so I'm controlling that also with the fall off, where I do a subtract and a max by myself. But here the subtract, instead of being by 1 like it's in the others, it's by 1.3. And the reason for that is that so I can have the cracks to show up a little bit ahead of time. Because if I have 1 in here, you notice that they only show up on the pieces that are already broken, and I want them to show up a little bit ahead of time. So I had 1.3 in here because of that. So now you can see that I have these cracks here showing up before the blast. I could also put, let's say, 1.5, and so, you know, bring those cracks more in. So I think 1.4 is fair. Right, so this is the effect. Maybe I could put this, let's say, on reflection, and also put the fall off of the interior also on the reflection, so I can have some brighter pieces going on. So this is what I get out of that transition. Yeah, reflection's a bit too harsh, probably not so good. But yeah, this is the sort of transition that could build up with this effect. I'm just going to render here a VPR preview so we can check what's going on. Okay, so let's check the preview. Looks something like this, and I think it looks fair. A bit of a confetti effect, but I think it's fair. Maybe the scaling down looks a bit weird. You might also want to check a scene that I shared with the community, where I also use a bunny, but instead of being fractured pieces, it's with hexagons. And so there's some other things that you might take from that scene. But overall, I'm going to consider this one done. So cheers.